Um, call it our tests. We're going to have several tests for series convergence or divergence. Some tests will tell us if a particular series converges. Some tests will tell us if it diverges. But we'll look at several of these as we go along here today. First one we're going to start off with is the geometric series. We talked about a little bit about geometric sequences, and so very much related to those are geometric series. If you look at these 1/2, 1/4, they'll give these series both ways, written out and in a formula form. But isn't that a geometric? That one's geometric. What makes that geometric? It has a common ratio, right, between terms. What is my common ratio R here? 1/2. Yeah, the common ratio will be 1/2. Each time I'm multiplying by 1/2 to get the next term, so that means my R is 1/2. You could say. So that's a geometric series, just like it's a geometric sequence if it was in sequence format. Okay, then we have 2, 6, 18, 54. That's a geometric. R is 3. And this one's geometric. 1 negative 2/3 plus 4/9 minus 8/27 16/81 minus blah, blah, blah. Alternating, we can have geometric series that alternate. That's a geometric series. R is what there? Negative 2/3. Yeah, the ratio is going to be a negative when it alternates. Okay, well, this also then, we note here, let me just back up here, this one is 1/2 to the n, or 1/2 to the n, let's write it that way. This would be the series of 1/2 to the n, right? Because the first term is 1/2, second term is 1/4, so I could write it that way. This one I could write as the sum of 2 times 3 to the n minus 1. That's one way I could write it. Have to make a little adjustment for that being 2 there instead of 3. And then this one is negative 2/3 to the n minus 1. Do you believe that? So we note there why, or what is the significance of the a sub n. For a geometric series, the a sub n is what type of expression? The a sub n is exponential, isn't it? Yeah, if I have an exponential expression for my a sub n is an exponential, meaning that n is in the exponent, nowhere else occurring. It's a geometric series. Now, it is important to note here that, for example, this one, there's other forms that this one could look like. This one could be written as, I think someone said earlier, that one could look like that. it also could be, what's another way that could be looking like? 2 to the minus n? Wouldn't that be the same as that? So this is, of course, the preferred form because of what we're going to talk about here in just a second. This is the preferred form, but these other forms it can look like as well. Okay? All right. Now, let me go ahead and mention this one. I can write this one a little differently too. Sometimes we may need to do this. This one could look like 2 times 3 to the n times 3 to the negative 1, couldn't it? Couldn't I break up that 3 to the n minus 1? 3 to the n, 3 to the minus 1? What's 3 to the minus 1? It's 1/3, isn't it? So another format of this series is 2/3, 3 to the n. That'd be another way we could do that. So it's important to know how to manipulate these things. Sometimes you may need to do that. Okay, now, also from these 3 here, we can also kind of see that, what about this one? Is that one going to actually have a sum? Can I sum up these terms? Those are just going to keep getting bigger and bigger and bigger, right? That one's going to diverge. So that series diverges. I can obviously see that because the numbers just keep growing larger and larger and larger. Whereas these other two, it looks like those, since the terms themselves are going to 0, that's not always true, but yeah, it turns out this one converges, this one doesn't. It's all hinging upon the R, which is right there, if I've got it written in that format. Yeah, let me say, since I've got it here, my notes, let me back up just to getting back to more to this. Okay. So let's say we've got the series 5 to the n plus 2 over 6 to the n plus 1. Is that one geometric? If so, what is R? Think so? Yeah, if I do what I did, this is what I was talking about there. 5 to the n plus 2 is 5 to the n times 5 to the second. This is 6 to the n times 6 to the first. So if I write that in my normal a sub n geometric sequence format, series format. Yeah, I'm with you there. It is 5 over 6. Yes, it's geometric. This is the ratio R, isn't it? Okay. All right. So sometimes we might need to go about that. Okay. Now, what I was going to allude to earlier is whether or not this series actually does converge to a number is hinging upon the R. The R tells me whether or not the series does converge. Does anybody know when it does converge? Well, we talked about this on the sequences, and it is the same pretty much. Maybe one slight little difference. Turns out, yeah, for a geometric series, if R is between -1 and +1, the series converges. And matter of fact, it converges to S, let's say S equals, the sum equals A over 1 minus R, where A is the first term, R is the ratio of your sequence. Huh? That's right. Yeah, so what's different about this and the sequence, whether it converges or not? Well, the sequence, yeah, if it was equal to 1, it converged. But not in the case of the series. It's strictly between. And so what that means is then if R is greater than equal to 1 or R is less than or equal to negative 1, the geometric series diverges. So this is if you want to call it our first test for series, because we're going to have multiple tests. Okay, all about the test. This is our first one, and the good thing about this test is we actually can say what the series converges to. We won't always be able to say that, but the geometric series converges to first term divided by 1 minus the ratio. Okay? All right, so here's one example. Series is 1/4 to the n minus 1. Does series converge or diverge? This one's convergent, isn't it? Why is this one convergent? It's geometric. R equals 1/4. And I'll go ahead and make this point. When you tell me something converges, tell me why it converges. And that's a good enough reason right there. Okay? Geometric, R equals 4. Yes, this is convergent. All right, what is then it convergent to? What is the actual value? Well, I can say 1/4 the n minus 1, what that actually equals by using the formula. It's A over 1 minus R. A is the first term, so the first term, there's no index given here. It starts at 1. So the first term is going to be 1/4 to the 1 minus 1 power, which is 1/4 of 0, which is 1. So 1's the first term. R is 1/4. So it's 1 over 3/4, which is 4/3. So this whole entire series converges to 4/3, 1 1/3. Add up all the terms of that series, infinite series. Still can add up all the terms. Okay. Here's another one. 2 plus 2/3 plus 2/9 plus 2/27. Gonna find this sum? And the answer is, of course, yes, we can. Why can we find this sum? Well, look at it. This is one where, yeah, you might want to put it in the series format, come up with a sub n, whatever. Summation notation. Yeah, it may not be. You may not have to put it in there, but put it in that form. We could. But just notice here, yeah, if we've, as we go along here, this is times 2/3 times 2/3 times 2. Yeah, this is a geometric. R equals 2/3. I don't think they'll make it good. Huh? 1/3. Yes, thank you. R, that's a big jump there. Thank you. R is 1/3. So the sum is going to be A over 1 minus R. First term is 2. R is 1/3. So it's 2 over 2/3, which is 2 times 3/2, which is 3. Sum up just to be 3. Okay, what about this one? 2 minus 10/3 plus 50 over 9 minus 250 over 27 plus ... Negative 5/3. Is that going to work? Geometric? Yeah, negative 5/3 times that. Negative 5/3 times that. Why is this one? That was negative 5/3 times that, isn't it? Too. So it all works. So it is geometric negative 5/3. So what's the sum? There is no sum. Why not? Yeah, R is less than negative 1, isn't it? And if R is less than negative 1, if it's not between negative 1 and positive 1, you cannot sum the geometric series. So, yeah, this, in essence, is, I guess it's too small, but it's not in the range of summable geometric series for R. All right. So the series is divergent. This one's divergent. Okay. I think we got that. Yeah. Now, let's do one. So one more of these, I think. That's all I'm going to do. One more. What about? Oh, well, I guess I should do 2 more. Find the sum, if possible. Is this one possible? Is it geometric? Sure. Got a geometric. What's my R? Is R3? That's not 3, is it? It's 1/3. Be 1/3. Yeah, it's, again, think here, 3 to the n, 3 to the negative 2. Then you can put these two together. Say it's 1/3 to the n, and that actually would be 3 squared. Yeah, so R is 1/3. So yeah, this one is summable. What's the sum? So it'll be A over 1 minus R. First term would be 9. 3? No. 3. Yeah, 3. First term is 3. The ratio is 1/3, so it's 3 over 2/3. Which is 3 times 3/2, which is 9/2. One more. Is that okay? What about 4 negative 2/3 to the n minus 1? Yeah, this one's geometric. R equals negative 2/3. Is that one summable? Yeah. It's in between negative 1 and positive 1, so yeah, I can find the sum. So the sum is going to be A over 1 minus R. First term. Yeah. First term would be 4 times negative 2/3. 0 minus 1 is negative 1. What you got there? 4/3 basically times negative 3/2, wouldn't it? Which is negative 6. Negative 6 first term. 1 minus, the r is negative 2/3. That's why I wanted to mention this one. Yeah, I've got a negative 2/3 is r. This is, the whole thing is r. So that'd be negative 6 over 1 plus 2/3. So you wind up adding, in that case, so we get, what, 5/3? Which is negative 6 times 3/5, which is negative 18/5. Okay, so gotta make a little note there. Christian? Did I mess it up? That's good because I've got it that way in my notes. So if I was going to have to fix my notes if I didn't have that. Yeah, this is wrong. Sorry. Yeah, because it's I started at 0, didn't I? 1 minus 1 gives you 0. So yeah, it wasn't as fun as I thought. 4 is the first term. 12/5. That's what I have in my notes. So I won't have to fix those. Fix it on the board. All right. See the thing. Now, one other. I lied. I got one more for you. Is that one convergent? Three to the n plus 2, 2 to the 4n. Huh? Convergent? Not convergent. Divergent? Let's see. What's the ratio here? It's all hinging on that, isn't it? It's a geometric, that's for sure. 3 over something. Okay. Yeah, so let's change this. It'll be 3 to the n times 3 to the second, 2 to the fourth. Let's see. 2 to the 2 to the fourth to the n. Say it that way. Yeah, if I have a number times the n, I can write it this way, which is 16. So I have 3 to the n times 9 over 16 to the n. So yeah, that's 3/16 to the n. Geometric. R equals 3/16, so it's converged. What does it converge to? Well, a over 1 minus r is what it converges to. The first term, 3/16 times 9, 27/16. Over 1 minus 3/16. Is that right? So it's 27/16 over 13/16, which is 27/16 times 16 over 3, 16 over 13. 16s cancel, 27/13. Okay.